A lot of people will talk about you have to teach yourself to talk to the AI. No, I'm not going to teach myself to talk to the AI. The AI can learn how to deal with me because that's where hallucinations come from. These public models were trained on the internet, and there are dozens of really good pieces of information on the internet. There are also hundreds of really bad pieces of information on the internet. He actually ran this exact same type of a thing, not using LM Studio, but Olama, and ran it on a Catalyst 9300 switch.
Yeah.
Right, Raspberry Pi. It doesn't take a lot.
Everyone, David Bombal back with the amazing Hank Preston. Hank, great to see you, man.
David, it's great, man. It is a pleasure, honestly, to be able to show up at these events and get the chance to sit down with you in person. It's a far cry from having to do this over WebEx and video and all that.
So much better, so much better. You've got a great demo today. AI, network engineers. Is there some kind of connection, like real-world examples that you can show us of how AI is actually practical today for network engineers?
Yeah, it's a great point. I mean, AI is everywhere.
Yeah.
And we've been doing this for a long time. I did the same thing in automation. I always wanted to find the ways that it was practical and take some of the hype away.
Yeah.
And so what I've been trying to do is to find these areas that can make the work that we have to do as network engineers useful and aspects that AI can factor in. I'm just scratching the surface at this point. I still like to tell everybody and remind them I have no idea what's going on with AI. I don't have all the answers. I don't know what's going to happen in the future, but I've got some interesting ideas and trying to figure out how it's been useful for my own life. And so I've got a handful of demos, different tools that we're going to look at and kind of see where we go into it. All right, so we'll start with the Kleenex, what I refer to as the Kleenex of AI these days, Chat GPT. It's the one that's out. It's the one that kind of made everybody recognize there was something here. And so we're going to start out with something that this is actually a demonstration based on I did during an actual lecture I was giving.
Okay.
I was talking about a bunch of different kind of technology topics, and I mentioned error detection, something we have to detect in packets when there's problems. And then a little later, we were also talking about something else, and message integrity came up. And I was like, well, we want to make sure the packets are in good shape. And someone's like, what's the difference between error detection and message integrity?
That's
and
a good one.
I was trying to stumble through, and I was like, well, I could phrase it out, but let's see what AI has to do. So I'm going to go in and say, what is the difference between error detection and message integrity in computer networking? Now, I will spell check it because I will, but you usually don't have to even. So what do we get? In computer networking, error detection and message integrity are closely related, but serve different purposes. And here's the breakdown. The goal, identify errors in data transmission. How does it work? Parity, checksums, CRC errors, all accurate. Limitations, only to detect unintentional changes. It doesn't protect against malicious alteration, which is where, ideally, message integrity comes in. Ensure it has not been altered either accidentally or intentionally by an attacker. Different cryptographic techniques are used, right? Breaks it down, kind of gives you the pieces. Stronger guarantee against accidental error, deliberate tampering, right? And then, oh man, it even gives us a nice table. The main purpose breaks it down. Now, when I was asked that question, I knew the answer and I would have gotten there, but this was able to kind of distill it down. Now, one of the things that's important for me, and I always talk with folks about AI is prone to hallucinations.
Yep.
It doesn't always give you exactly the right answer. So one of my favorite uses or things just to remember is to use AI to find those the pieces of information that are buried in my brain and just help me dust them off because I can recognize the right answer. And so that's a great area just to kind of quickly take advantage of the fact that I'm getting older and it's getting harder to remember everything that's in my head.
And that doesn't judge you. That's what's great about AI.
Yeah, that's true. Unless you tell it that you want to be judged by your questions. That's a different demo. We will go into that
another day.
Yeah, as it goes through. And so we get a conclusion, basic as it goes through. So that's a ridiculously kind of useful use case that goes in. Now, one of the other ones that I like is we get, as network engineers, documentation in Visio diagrams or network diagrams that are out there. And then we've got to process it, understand what's there. So for this one, I'm going to show an example. I have this example network diagram. So what this network diagram is, it actually came from Cisco Live Amsterdam just in February. And it's a public diagram, which is why I'm allowed to use it here.
Great.
But this is the core network, and it kind of describes how the network at Cisco Live Amsterdam is kind of configured. There's all sorts of details that are in here. It's an interesting documentation. So maybe I wanted to understand more about this. So this is the JPEG, and I'm going to switch tools this time just to show some other ones. So Chat GPT is great. Mistral AI is another tool that's out there. This is put together by, it's actually LeChat is the tool. Mistral AI, it's a French startup out of Europe. And they've been doing some interesting things and adding new capabilities. And so what we'll do here is I'm going to go ahead and I'm going to upload and attach this file. And let me go find it. So I'm going to grab that same file here and I'm going to go ahead and attach it to this chat. So it shows up in the piece. And I'm just going to ask, can you summarize the network from this topology file. So it's going to go ahead and process through that, pulls it in. And this part's pretty cool because there's a lot of detail that you can get in some of these network diagrams. And so it processes for a minute. It does take a little bit of time. All right, here we go. So it appears to represent a complex network infrastructure, likely for an enterprise or data center. It's got some core network infrastructure. So it was able to kind of pull different aspects of the network that's out there. So core 1, core 2 shows me the interconnections. They're interconnected with various types of speed, 10 gig, 40, 100 gig. Could pull that out from something on the diagram. Distribution layer, access layer, there's a server room, there's network devices. Looks like there were some goals for generating a core diagram, automating. So it kind of just pulling all the stuff that's in place. Overall, well-structured. I think the Cisco Live NOC team would appreciate that.
Exactly.
Redundant. It's definitely redundant and high-performant. So it's done a processing, but I can go deeper in here. Can you give me a list of all the network devices?
That's good. But what I'm seeing is, you know what prompts to ask, right?
Well, it's prompting, and a big part of AI is prompt engineering is a term. My perspective, which seems to be a little different. A lot of people will talk about you have to teach yourself to talk to the AI, and I'm like, no, I'm not going to teach myself to talk to the AI. The AI can learn how to deal with me.
Look at me, sure. I'm the captain now.
I like that.
Right, that's the way I approach this. So I don't put a lot of effort into these. I really just talk to it like I'm after it. Not rude, right? I'm a polite, because at some point the AI may take over the world, and I want it to know that I'm on board for this. Like I've been a polite user over the years, but I don't put a lot of effort into it. I just kind of tell it what I'm trying to do, and it's pretty good about figuring it out. But here, so I've got a nice list of devices. It even gives me the model numbers. I was going to ask for those next, but it went through. Now this will go in. It's actually a good example right here. So it's artificial intelligence. It's doing processing of the diagram. It doesn't always get things perfect. So clearly the C100, 4T, and S is probably not the proper model number. So you do have to check the work, but it'll get you really close.
But it saved you trying to do that manually.
Right, and I'll show you the next step for this as well, which is really cool. So it gives me the nice list of the devices that are there, and I'm like, that's awesome. Now, what might I need to do with this? So let's say I'm a network engineer on this team, and I've been given this diagram, and I need to start processing, going through on that. I need to take that and turn it into something I can work with. So how about this? Can you generate a CSV file of the network devices, include columns for the host name, model, and management IP address? I'm going to process, and sure enough, here it starts to generate. Now, like the model numbers from above, I've done this, kind of shown this demo a few times, and it's not always perfect on the IP addresses because there's a lot of IP addresses on that diagram. And so it doesn't always process and grab exactly the right ones. You can give it some more information. Hey, it's this IP address, or it's in bold. Or you can use it as a starting point and then just spot check it and go through or fix it as it goes in. But this certainly would have sped me up and given me a starting point to go through.
Yep.
So network diagram processing is a really interesting one, particularly if you've got a lot of documentation that you're absorbing from a new network. Maybe you're in a class or a book and you grab something and you just want to kind of talk to the diagram and get information. I really like this use case, and it pulls it out.
Oh, it's good.
It's a fantastic one that goes in on that side. And then you could take this and you could continue to go through all sorts of different areas. Now, AI can also create network diagrams and images, and I've tried a few different examples on that, and I haven't found a good way to go through. One of the ones that I tried that was okay is I've got an iPad. I don't have it with me right now, but an iPad with a pen, and I sketch something out, and then I'll put it up and say, hey, can you generate a network diagram based on this? What's interesting about it, the creativity of AI comes in. So what it decides to use for different icons and colors that go through. But that's one that I'm kind of interested to see. I'm sure at some point some of these these diagramming tools will get that, where you can just sketch it and boom, it'll turn it into. But the diagram manipulation is kind of an interesting one to go at. So that's my second one. Any thoughts, questions?
That's good. My concern is always, but I think it's just because I'm a grumpy old network engineer, it's the hallucinations.
It is. And you have to be aware of it. They're going to happen.
Yeah.
They're going to happen all the time. I think you know Joe Clark from our team. Joe's a big EM guy. And he tells a story about he was sitting around and somebody came up to him and said, hey, can you check this EM configuration? It's not working for me right. And Joe's been doing EM for years. He's the guy. And so he's looking at it. He's like, it looks right. And he goes through and he starts by, he's like, this part looks a little weird, but it looks like a legit configuration. Come to find out the engineer had used Chat GPT to generate an EM configuration, and it generated what looked like a really good,
that's the
but it
problem.
was pulling new features in and things that were there. Then Joe's like, I'm gonna have to check to see if that's supported. Yeah, it was complete hallucinations that are out there. So you do have to be careful and aware that's there. But I've got something I want to show you next that potentially gives us a way to minimize the hallucinations.
Okay, good. I'm glad you've got something. Because that's the problem, right? You can spend more time trying to check it versus just making it.
Yeah, absolutely. So minimizing hallucinations is always a piece that's in there. So I'm going to stick on Mistral for this one. And so what I like here is Mistral has a feature called libraries, where I've gone ahead and I've downloaded all of the PDFs for the iOS XE configuration guides from Cisco.com.
Well done.
They're all public.
Yeah.
All right, so this is all public information. I just uploaded into this library, and I'm going to go in and say, I want to ask a question, right? And now I've been playing with Mistral a little bit. You would think that it would assume that I wanted it to use that library to answer this question. It doesn't always assume that. So I'm going to specifically say, using the Cisco documentation library, can you tell me how to check the status of my IPsec VPNs, both phase 1 and phase 2. All right, let's see how it goes this time. There it goes. See, what we see is it picked up. It says it worked for a few seconds, right? And you can actually look at it, search the libraries, check status for here. And it says, all right, to check it, we've got phase 1, show ISO crypto ISOCamp. Phase 2, show crypto IPsec SA. You want to see the details. And it gives me all this information that's in place. And it kind of goes ahead and pulls that information from the documentation. So we've filtered down to a good set of data.
Yeah.
Because that's where hallucinations come from. These public models were trained on the internet. And there are dozens of really good pieces of information on the internet. There are also hundreds of really bad pieces of information on the internet. If you can hone it in to kind of look at just specific pieces. And so this one I really like, because reading through all of those manuals and finding the piece can be tough. But you can use the library. And I really enjoy this. And the fact that it's built in, and obviously you could upgrade to the Pro and pay, but even the free version of Mistral gives you this access to this type of an option.
That's nice. That's really good.
This is a cool one. And you can chat at it. And that's why they'll let you upload a bunch of documentation. You can create different libraries. I created one that has a bunch of IETF standards. So if I want to ask questions about those and just chat with them. And so this is something that I really like this feature.
We were starting to read RFCs, right?
I know. They're all there and they go.
You can upload a whole bunch of RFCs if you really want to.
Yep.
That's good. I like that.
So the next time I'm going to show you is what we've looked at so far. Everything has been using cloud-based models,
Yep.
Chat GPT, Mistral. One of the things we have to pay attention to with AI is as soon as you post something into any of these tools, unless you happen to have a contract with that company that says your data is yours and it's negotiated and that costs money, you got to be a big company sometimes to do that. You've basically given them access to it to do whatever it is.
Yeah.
And there's certain things we have to do as network engineers that don't allow for that.
Yep.
And so what I want to show now is we have the ability to actually run models directly on our workstation. So I'm going to open up this application called LM Studio. It's a free application that you can download, and you can grab any of a number of different models and run them on your laptop.
DeepSeek, number one. I like it.
Yeah, apparently it's the studio staff pick that's in there. The one that I'm using is the Llama model. So we got a bunch of different flavors of the Llama model. Now, in order to run a model, you have to have enough resources on your machine. So if I pick like this one here, this model shows only 2.02 gigabytes. That'll easily run on my laptop. If I jump down to one of these other ones, so for example, this one, let's find a big one. That one's 8 gigs. So my laptop's got enough RAM. I could run that one. Here we go, 13 billion. So I'm good on that one. Where's one of the big Llama models? Oh, there it is, the 70 billion one. So this model is one of the ones like that you'd need like a very large system to go. And it even tells me likely too large. So you find the model that you can run on your machine. Now, most of our laptops these days have a GPU in them, right? My Mac's got one, a Windows PC will have one. And the applications can actually kind of grab a hold and just take advantage of your GPU to send and take advantage to use those. If you don't have a GPU, it can do it in the CPU. It's just a little slower.
Yep.
But where we'll go in here, I'm going to start a new chat on this. And so for this example is, let's say you're a network engineer and you're working on building up and submitting an RFP for a bunch of vendors and service providers to give you quotes.
Yeah.
Right? That's probably a bunch of data that you don't necessarily want to send off to these public internet providers because it's going to have some of your data in there. And so we can use a model running right on my laptop for this. So I'm going to go ahead and paste in kind of a put together RFP prompts. And so I just want an RFP proposal document to send to some partners for this project. It's VXLAN and EVPN, right? The proposal needs to include some suggestions for hardware, services, training information, give it details, hit enter. And right on my laptop, again, I could disconnect from the internet, all that stuff. This is right here, just running on my laptop, gives me a nice breakdown. I could talk with this and say, okay, I can start giving it more of my specific details. These are the sites that are important. We need to make sure that we've got these areas and these considerations. And I don't have to worry about sending this data elsewhere. And I don't have to be an AI expert, right? I don't need this giant cluster in the data center. Most modern laptops can do this without an issue. In fact, John Capobianco, you know
John's
him.
great.
One of the projects he did is he actually ran this exact same type of a thing, not using LM Studio, but Olama, and ran it on a Catalyst 9300 switch.
Yeah.
Right, Raspberry Pi. It doesn't take a lot. It's faster if you got some hardware, but even on a regular laptop, you can have your own AI to chat with as it goes through.
That's great.
Super.
I like that because, I mean, he's got the time to write stuff like that.
Absolutely not. Now, so you'll have to customize it, or maybe you just take it and send it away. Depends on how good it comes out.
The hardest thing is to start with a blank piece of paper. Yeah. It's much easier to take something like that and then adjust it.
Mm-hmm.
Yeah.
All right. So I've got one more demo I'll show you, and I think you'll appreciate this one. I'm going to stick in LM Studio because it's a decent place to do it.
Yep.
But let's say this. I occasionally get asked to go into the middle school back at home and for like career day or STEM day and talk about what we're doing. And so it's hard sometimes to explain and put together a short talk targeting at like middle school students.
Yes.
And so I'm going to go in and ask. I've been asked to give a 5-minute presentation to some middle school students about computer networking and being a network engineer. Could you help me with a short speech? All right, we'll spell check this just because I'm a little bit specific, although again, you usually don't have to worry about that. And I'll send that off and it says, great. Here's a possible 5-minute presentation on computer network engineering for middle school students. Your introduction, what is computer networking? Stop it from scrolling. You know how roads have signs and maps to help us navigate? Computer networks work in a similar way. The roads or cables or Wi-Fi. It provides analogies that are relevant in that space.
That's
and
good.
It breaks it down in these different sections as you can kind of hammer into it. In conclusion, thanks for listening to me to go through on that
That's
side.
good.
I like this.
Again, you don't start with a blank piece of paper. It gives you something to start with.
All right, so one final demo that goes through because we got to do something fun, right? These have all been very useful, but we'll do something fun. So what if we wanted to, let's say, I would like to explain how spanning tree works as if I was a pirate.
Pirates.
All right. So here be a tale of spanning tree told in pirate speak. Our land lovers, you know that connecting all your devices to the ship or network be a good thing, right? I got a treasure to share. And it will go through and explain spanning tree and the fundamentals of how
And that's
it goes.
on your laptop.
And this is, again, just on my laptop. If you go to some of the bigger models, Chat GPT's actually got a lot of like interesting stuff and you can get some fun stuff from there. But I wanted to do it here to show that you don't need those big models to do a lot of things. We're so used to like these massive things from Gemini or Google or Copilot or Chat GPT. Just these things that you can run. Everything here is the open source model Llama that's in place. I'm running on my laptop. And you just have a lot of fun with these pieces that are there and kind of dive in. And so what I've learned as I've gone in, there's a lot of hype about AI, right? And you, as a network engineer, we're being told about the infrastructure we have to build and all of that. Totally valid. But the truth of the matter is most network engineers and most organizations are not building large-scale infrastructure for AI yet.
Yeah.
Right? There are some, and we have to make sure we're supplied. But network engineers can make our jobs easier by kind of figuring out ways that we can leverage AI to make us better network engineers. And that's my focus, and what I've been trying to dive into is to find use cases like this that will offer people that type of an ability. I'm not trying to replace network engineers. Nothing I did here today would replace a network engineer. It just takes us some time away, like helps us speed up with what we're after. And it's just the start of the iceberg here. There's so much more we can dive into in this space.
I think, like as older guys, it's a bit of a learning curve, but it really empowers you.
Oh, yeah.
Saves you so much time.
Yeah. So I encourage everybody that's watching, if you haven't dove into this yet, take a look at it. So if you're new to AI and you're really getting started, the best place I recommend to go is over on netacad.com. So just netacad.com. My favorite AI course is just Introduction to Modern AI. It's 6 hours.
Free, right?
It's free, yeah, 100% free to everybody. It's like 6 hours of video, and a guy on my team, right, from Netacad, his name's Eddie Shu. Oh my God, he's hilarious in this session. He breaks down what AI is, all the different aspects, shows you the use cases, explains the difference between Gen AI in a way that anybody can figure it out. I've sent this course to my mom to say, go watch this to understand what all this hype is about. And it's an excellent place to get started. And then after you've got your hands around that, I mean, I'm going to send you to Cisco U, right? We're learn with Cisco. So go over to Cisco U, and we have so many tutorials and courses that will help you understand prompt engineering for a network engineer, how Chat GPT can be integrated with stuff. And we're starting to dive into some of the integration areas so that you can chat with your network. Definitely keep up. We're constantly bringing new information out there and trying to target things that are useful for folks like us. We're network engineers. We're trying to do the job. So,
Hank, as always, love it, man. Thanks. Appreciate it.
yeah, I appreciate it. Thanks for having me come, man. This has been so much fun.